Welcome back to Year 9. Yesterday's lesson, we were talking about factorising these trinomial things of the form ax squared plus bx plus c. We were all about putting brackets and then getting, x plus something, x takes something, or whatever ended up being appropriate for the situation. Either way, factorising, we're putting in brackets. Now, yesterday, if you look carefully at what I actually went through with you, we only did cases where there was no number out the front of the x squared. It was essentially, we only looked at situations where we had one x squared. Each of the three examples we did, in effect, we just had a 1x squared at the front when we came to factorising. Even the one where we pulled the common factor out first, we then only dealt with factorising a 1x squared. Today, we get to use exactly the same technique that we went through in the previous lesson, except we're going to apply it to situations where we genuinely have something out the front of the x squared and there's not an easy, simple way of factorising it first to make it easier. So that's today, using our same technique, the crisscross method for factorisation, except in some more interesting and difficult examples. So, shouldn't take too long to go through this one actually, I'm hoping. So I'm going to take the examples from the book, but I'm not going to do it anywhere near like what the book does it. So here we go. Example number 1. We have 2x squared plus 7x plus 3. This is a nice one to start with because it's got no negatives in it. Negatives, yeah, you have to be really comfortable with your addition, multiplication and whatnot of negative numbers before you can do those. So let's look at this from the start. What's the first thing we always do to factorise? We draw up our table. So we draw up our table as normal. I'm still going to put the ax squared component in here. I'm still going to put the c component in here. So this time the ax squared component is 2x squared. The c component, the constant, no algebra with it, no variables, is 3. So that's the table setup. Always do the table setup first. Now, in effect, let's write down this process. We do the table, we find the solution, and we make sure to state the answer. That's what we're doing every time. So in this case, instead of it just being x times x, what can multiply together to give 2x squared? The most obvious possibility would be 2x times x. Not really a lot of other possibilities at this stage. 3, again, that's it's not a too difficult example here. It can only be 1 or 1 times 3 if you're sticking to whole numbers. So I'll just write 1 and 3. And I know from right now, I know if I get this wrong, all I'm going to do is swap those two around and it'll give me the right answer. But let's see if we've got the right answer straight away. We do our crisscross. So that's going to give us 2x times 3. It's going to give us 6x plus 1x, which is 7x. We're after the bx component. Oh, we got it. There we go. That one's solved first go. Sometimes that's going to happen. If I'd had the 1 and 3 flipped around, it would have given me 2x plus 3x. It would have given me 5x. So if I had those two the other way around, it wouldn't have worked. It just happened we got that right first off. So we found the solution, and in the end we just need to state that, well, I'll write it out fully. 2x squared plus 7x plus 3, our original question, is equal to 2x plus 1 times x plus 3. Remember, you can just put the brackets around it once you've got the solution. That's all I've done there. So you see how the technique from the previous lesson actually works very well with these more difficult examples. I'm just going to get the next step. We're going to do 2 more examples, ones that start having negatives in them. I might get a chair. Going to get all comfortable. Are you all comfortable out there? Are you enjoying yourselves? I'm quite happy making videos for you guys. I think you'll actually probably even watch them, which is great, especially if you get something out of them and it works for you. This is really, really powerful stuff for a lot of mathematical techniques that you're going to go into later. So I hope we're going okay. Let me know if you're not. But always, let me know exactly which line the confusion starts at so we can work from there if you have any trouble. Second example is going to be 10x squared plus 9x take 9. So again, first step, always draw the table. We put the ax squared part in first, which is 10x squared. I put the c component in second, which is negative 9. These ones, you can start ending up having quite a few solutions before you get it. So let's start and see how we go. It's always a bit of an adventure because I like you to see me think. I haven't done this one before using this technique. I can't even see the answer over there, thankfully. It's not there, so I'm not cheating, don't worry. 10x squared. All right, first up I'm going to try 5x and 2x. Because 5x times 2x will give us a 10x squared. Here, negative 9. Well, look, it's got to be positive in the end. So I'm going to put 3 and negative 3 there. Whoops, I have a bad feeling I've just accidentally solved it first go. Anyway, I know bx has to be positive, so I'm trying to make it that the positive diagonal is going to be bigger, if that makes sense. Draw our cross here. That's going to give me 15x plus negative 6x, which is the same as just take 6x. I'll write it as just take 6x, which is 9x. Again, that was a complete freak by chance occurrence there. Normally you would have had to try a few combinations before getting that out. I thought it was going to take more than that. But anyway, we've already got it. So it's 5x take 3, 2x plus 3. Actually, one of the things I haven't shown you, which I will do given that went so quickly, is how could I check that's correct? Anyone? All I can hear is the birds and the clock ticking in the background. It's really strange. It's terribly quiet here. I could expand it. I could expand this and check that I get what I should. I should get that original expression. So I'll just note that. You can check by expanding. And I'll do that quickly for this one. So we have our 5x take 3, 2x plus 3. Draw the claw. All right, so that gives us 5x times 2x, which is 10x squared. 5x times positive 3, which is 15x. Negative 3 times 2x, which is negative 6x. And negative 3 times positive 3, which is negative 9. We have like terms in the middle. These things are just x on them. So 15 take away 6 is indeed 9. So you're going to get 10x squared plus 9x take away 9. Was that original question? Yes, it was. Fantastic. We have verified. If we want to use a technical word, we have verified that we got the correct answer. All right, so I think we'll do just one more example, and then hopefully you're going to be able to go forth into the world and factorise. So, trying to fit it all into one board so that hopefully it looks a little bit better on the video. The ones I do at home, I have a board that's only about this big. It's a lot of fun. All right, so the last one here, I am nicking the questions from the book, but not the answers. 6x squared, subtract 17x plus 12. Right, so again, what do we do first? Should see you drawing a beautiful table. We're going to put the ax squared component in first and the c component in the second part. Oh, this is one of those cases where it has to add to be a negative, which kind of gives away that it has to be a negative times a negative when we split this up. We've had that before in the previous lesson. So I'm going to pick something random here, 6x squared. I'm going to go 3x times 2x. It could also be 1x times 6x. We don't know that yet. 12, I'll go for negative 3 and negative 4. It has to be two negatives multiplied together. And let's see what we get. So this time I've got negative 12x plus negative 6x, which is negative 18x. That is not the solution because I needed negative 17x. So, where do we go next? Both of them were giving even answers. I wonder what happens if we just swap those two. 3x, 2x, so I'm going to go negative 4 up the top and negative 3 on the bottom because that's going to completely change the numbers. Sorry if that bell gave you a fright there. It's probably pretty weird on the video. Alright, so 3x times negative 3, this time we get negative 9x plus negative 8. We got it! Negative 9 take away 8, you get negative 17x. We got it. Isn't that great? Okay, don't get too excited. So the answer, I say our old question, 6x squared take 17x plus 12 is equal to 3x take 4 times 2x take 3. Alright, remember again, once you've got the solution, you can just put the brackets around it and you're done. Well, in fact, I might, in my head, just quickly check I've got that right. That'd be a 6x squared, negative 9x, negative 8x, which would give me the negative 17, and negative 4 times negative 3, which would be positive 12. If you expand that out, it does work. You could verify it that way as we did down there. I just did it in my head a bit quickly, but you want the marks, so you should actually show it being done. All right, so that's it, guys. Over this lesson and the last lesson, I've gone through factorising trinomials with you. All cases, not just ones where you have 1x squared, where you have x squared by itself. We've also done the cases where you've got a number out the front of the x squared. Do look for common factors first. If you ever do have common factors, extract them out. We looked at one like that yesterday. Otherwise, crisscross, ax squared component, c component, work out what multiplies together, try different combinations until you happen to find the solution. Lots of fun. Once you practice it a bit, you'll find it's not too bad and it's actually pretty chilled. So that's all for today. If you have any questions, dire trouble, please give me a yell. Thank you.